In this video, we're going to take a look at finding the minimum or maximum of a quadratic function, as well as stating the domain and range. Alright, so let's take a look at this first one. And when we talk about minimums and maximums in quadratic functions, well, remember that a quadratic function is in the shape of a parabola. So if it opens upward, we're going to have a minimum right here, because this is as low as it's going to go. All the other values are going up here, so if it opens upward, we're going to have a minimum. In the same way, if we have a parabola that opens downward, we're going to have a maximum, because, well, this is the largest value that we can get out right here. Everything else is going down this way. There are going to be no larger values that can come out of that function. So, how do we find it? Well, as we look at this, what is that special point that is at either the bottom if it opens up or the top if it opens down? That's our vertex. And the minimum or maximum is going to be the y value at the vertex. So, let's take a look at this first one. Remember, to find the vertex of a quadratic function written in standard form, which that is, we take negative b over 2a, and that's our x-coordinate, and then to find the y-coordinate, we put that in, so it's f of negative b over 2a. Okay, so we're going to use that, and then we're going to be able to find our minimum, our maximum of these particular quadratic functions. So, for this first one, I need to find that vertex, so I need to start by finding the x-coordinate. Well, for this one it's negative b, here's my b, which is negative 8, so negative 8 is just going to be a positive 8 over 2 times a, and here's our a, 2, so 2 times 2. Then, simplify that, we have 8 over 4. 2 times 2 is 4, of course. 8 divided by 4 is just 2. Okay, so that is my x-coordinate. Now I need to find the corresponding y-coordinate. So, I'm going to take that, put it in for x, and find out what I get out. So, 2 times x squared, well, x we found to be 2, the one that we're interested in. So 2 times 2 squared minus 8 times 2 plus 9. Oops. Plus 9. Okay, then order of operations says we have to do that exponent stuff first. So 2 squared, 2 times 2 is 4. 4 times 2 is 8. So we have 8. Then minus 8 times 2 would be minus 16. Then plus 9. Okay. Then 8 minus 16, that would be negative 8. And then plus 9 would be just 1. So, our vertex for this one is 2, 1. Okay, now, let's think about this for a second. 2, 1, that point, over 2, up 1. How do we know if it's a minimum or a maximum? Well, I could go ahead and do all the graphing, but I know since the a right here, this 2 is positive, that my parabola is opening upward. So something like this. So that's going to be a minimum. And the minimum value that can come out of there is the y-coordinate. So my minimum for this one is 1. Okay, then the domain and range. The domain for all quadratic functions is always all real numbers, because we can put anything in that we want. So x is an element in the real numbers. Let's make my fancy r there. Okay, and then my range, well, that's limited by whatever that minimum or maximum is. In this case, it's a minimum, so my y coming out there, or to be more proper, I should really put f of x, but that is greater than greater than or equal to 1, which was my minimum. So we know that everything that comes out of this quadratic function, because it opens upward, is going to be at most, or at least 1, but also greater. Okay, so that for this one, the minimum is 1, and it's a minimum because this is positive, so my parabola is opening upward. Let me just get another point here so we can sketch that in, so maybe that'll help us to understand and see what's going on. So I'm just going to use 1, and we'll see where it's at. It's going to be somewhere in this neighborhood, I'm guessing. So we put in 1. 1 squared would still be 1, so 2 times 1 is 2, minus 8 times 1 would just be 8. So 2 minus 8 would be negative 6, plus 9 would be 3. Okay, so we're up right here at 3. So 1, 3. Then I also know, since parabolas are symmetrical, that we have a point there. And then I can sketch, oops, let me try that again. That didn't turn out very well. Try and connect my dots here. Okay, and I can sketch my parabola like so. A little curvature that shouldn't be there, but we get the idea. Again, understanding that this is the smallest it can be. It's extending forever in this direction, so that it can get bigger, but it cannot get smaller. There's no way to get a negative number out of there. We can't do it, no matter what we put in. Okay, so let's take a look at this next one. In this one, we have the A is negative, so that means that the parabola is opening down, so we're going to have a maximum. Well, how do we find that maximum? The same way we find a minimum. We start by finding that vertex. So I'm going to take negative b over 2a. In this case, I have 6 for my b, so negative 6 over 2 times a. In this case, a is negative 3, so we have 3. Then negative 6 over 2 times negative 3 is also negative 6. So we simplify and we get 1. Okay, so that's my x-coordinate for my vertex, is at 1. Then, to find my y-coordinate, I'm going to go ahead and put that 1 in to my function and see what we get out. So, negative 3 times 1 squared plus 6. Oops, 6 didn't turn out very nicely. Let's try that again. 6 times 1 minus 4. Okay, 1 squared, well that's 1 times 1, which is still 1. So we have negative 3 plus 6 times 1, which is 6, and then minus 4. Okay, that's going to give us negative 3 plus 6 is 3, minus 4 would be negative 1. So my y-coordinate, in this case, is negative 1 on my vertex. Okay, so it would be over at 1, negative 1 is the vertex. Okay, so what does that mean? Well, the maximum for this one, since it's opening down, that means it's going to be something like this, is going to be negative 1. That's as high as it can get. So our maximum is negative 1. The domain, well, the domain is always all real numbers. We can put in whatever we want. So x is an element in the real numbers. And then my range, which is my f of x, more correctly, okay, is f of x is less than or equal to this, because all the numbers that come out are going to be at most negative 1, but most of them are going to be less than. So it's going to be less than, my parabola opens down. If I want to sketch that parabola quickly, I could put in, let's put in, actually, we don't even have to work so hard. Remember that in standard form, our y-intercept is right here, and in this case it's negative 4. So I'm just going to go down to -4, make another point, and then also remember, since it's symmetrical, there'll be one over here, and then we can connect the dots to make our parabola, just like so. So it makes sense that our maximum is -1 because we're going down after that. There's no way we can get a positive number out of this function no matter what we choose to put in. Again, finding the minimum or maximum of a quadratic function. To do that, first of all, we need to determine, is the function opening up or down? That'll tell us if it's a minimum or maximum. Then we find the vertex, and the minimum or maximum value is the y value at that vertex. Then we talked about the domain and the range. The domain is simply all real numbers for quadratic functions. There's no limits in terms of what we can put into the function. However, there will be a limit on what comes out, and we can find that by looking at that y value at the vertex, and then it's either going to be greater than or equal to that, or less than or equal to that, depending on if we're dealing with a parabola that's opening up or opening down. I hope this video was helpful. Keep working hard on your math. You can do it.